Question 13 of 2023 DSE Math Paper 1. So let's read the question first. So let's define the gx is a cubic equation, and we have hx, which is power 4 equations, the polynomial. And I told you that when hx is divided by gx, we have the quotient and the remainder are equal. Try to summarize it. So when hx divided by gx, then we have the quotient is equal to the remainder. So we can using the relationship between the dividend, divisor, quotient, and remainder, which is the dividend is equal to the divisor times the quotient and plus the remainder. So because the quotient and the remainder are the same, so we can let the qx be the quotient and the remainder. Then we can say our hx can be, hx is the dividend, is equal to the divisor, this time is the gx times qx plus qx. Then now we can take out the qx as the common factor. Then we have hx is equal to taking out the qx. Then we have gx plus 1. Then now we can put the hx and the gx back. Then we have hx, which is 3x power 4 plus ax power 3, 16x squared, plus bx plus c equal to the qx times gx, which is x to the power 3 plus 5x squared minus 12x minus 1. But don't forget this plus 1 to put it here back as well. So plus the 1. The negative 1 plus 1 giving you 0. So we have 3x squared plus ax cubed, just copy this down, is equal to qx times x3, 5x squared minus 12x. So now we have the dividend is equal to quotient times another factor. There's no more remainder here. So what we can do just to move this to the left hand side and make the qx be the subject. So we have the qx is equal to 3x4 plus ax cubed minus 16x squared plus bx plus c divided by x3 plus 5x squared minus 12x. But now you will see the problem is we have so many unknowns. How we do it using the short division or the long division is very hard to do it, isn't it? Then we need to think about another way. So this is a power 4 and this is a power 3. Then to make the left hand side and right hand side becomes the identities, which means that the qx must be a linear equation, which means that the highest power is going to be 1, because x times the x cubed will give you x to the power 4. So we don't need to write down this. Then we can just say, let qx be a linear factor, which is ax plus b. Be careful, we have this a, b, c already. So we'll be using mx plus n. Then we can say, copy this down, copy the whole thing. And I can just replace the qx by mx plus n. Then now we can try to expand the bracket and then compare the coefficients. So expand the bracket of the right hand side, we have mx cubed plus 5mx, mx to the power 4 plus 5mx cubed minus 12mx squared. So say again, mx times x cubed giving you x to the power 4, mx times 5x squared give you 5mx cubed, mx times negative 12x give you negative 12m squared. So do a similar thing for the n term as well. And then we plus nx cubed plus 5nx squared minus 12nx. Then group them together, we have this is equal to mx to the power 4 plus 5m plus n x cubed, and then plus 5n minus 12m x squared minus 12nx. Then now we can compare the coefficients for the coefficient of x to the power 4. So compare x to the power 4. We have n is equal to 3. Because a is the unknown, we don't need to find out a. Then to compare the second coefficient, which is the negative 16, the coefficient of x squared. Negative 16 equal to 5n minus 12n. we can compare the coefficient of x squared. Then we have negative 16 equal to 5n minus 12m. Then we can replace the m by 3. Negative 16 equal to 5n minus 12 times 3. Then we have negative 16 plus 36 equal to 5n. Solve the equation, we have n is equal to 4. So that's for part A. We haven't finished. The quotient, we just find out what is m and n, isn't it? Then we can say the quotient, the qx, we need to write it down, the mx plus n, isn't it? That's going to be 3x plus 4. The reason why I can write it down because we let the quotient because mx plus n, and I find out that m is equal to 3, together with the n is equal to 4. Then you can just replace the qx by 3x plus 4. That's for part A. And now we have to write down the part B. We have how many rational roots does the equation hx equal to 0 have? So rational roots means that can writing as a over b, writing as a function, and ab is going to be our integer. And the HCF of ab is equal to 1. So there's no more common factor between a and b, just wanted to be simplified. And make sure a and b are integer because pi over 2, even though it's a fraction, but we can't treat it as the rational root, okay? So let's do part B. So part B, we can write the hx equal to 0 first. So hx can be writing as this. Remember, hx is equal to qx times gx plus 1. Can copy that down. Qx is our 3x plus 4. So we can write hx is equal to qx times gx plus 1. That's what we found from part 1, part A. So qx, what we found is just equal to 3x plus 4. So we have 3x plus 4 times the gx, which is x cubed plus 5x squared minus 12x minus 1. Don't forget to plus the 1 here. And then we have 3x plus 4 times x cubed plus 5x squared minus 12x. And now we can take out the x as the common factor. So we have x times 3x plus 4. Then we have x squared plus 5x minus 12. Then using your formula 01, we have 3x plus 4 times... It's giving you some ugly numbers, isn't it? Then we can just leave it like this. And if we consider so we consider hx is equal to 0. So we have x is equal to 0, or 3x plus 4 equal to 0, or x squared plus 5x minus 12 equal to 0. Because 3 things times together equal to 0, then each of them will be equal to 0. So now we can say x is equal to 0 or x is equal to negative 4 over 3. Then how to solve this equation? We can use the quadratic formula, isn't it? So the x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So that we can say x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times a, which is 1, times c, which is negative 12. This is ax squared plus bx plus c. And then we need to divide it by the a, 2a, which is just 2 times 1. So the x is giving you negative 5 plus or minus 25 plus 48, giving you 73, divided by 2. So because negative 5 plus or minus square root 73 divided by 2 are not rational, even that is in a fraction part, fraction-like, but this part is not an integer, so it's going to be wrong. So the integer, the rational number is just 2 numbers. So how many rational roots? Then we have 2. So 2 rational roots.